Let f is a function defined from real set to real and satisfying the condition f x plus y equal to fx into fy, and this is true for all domain points. And the second condition is a limit x tends to 0 fx equal to 1. These two conditions of hypothesis and asked about function is strictly increasing. In option B, f is either constant or bounded, means boundedness and constant. Option C, fr into x equal to fx raised to the power r for every rational r coming from real number. And fx is greater than equal to 0 for all x belongs to R. It means all images of the function is greater than or equal to 0, means non-negative. So we will check each option one by one. For this, which satisfy the condition of hypothesis, we can consider function as fx equal to e raised to the power x, e raised to the power minus x, e raised to the power x. These are few examples which can satisfy the properties of given hypothesis. Now we will check each option one by one. So we know the graph of this commonly known function. This is the graph of e raised to the power x, and this is the graph of e raised to the power minus x. You can make a proper graph when limit x tends to 0, x tends to 0, fx equal to 1 for e raised to the power x and e raised to the power minus x. You can consider e raised to the power x also. If I consider this graph means fx equal to e raised to the power minus x, then option A discard. And in both the case, either e raised to the power x or e raised to the power minus x function is bounded from one sided but not from both sided, means all images cannot be less than a real number. And you can see e raised to the power x or e raised to the power minus x is neither a constant function. So option B is false. Now we're trying to check option C. As you can see, option C is as given f r into x equal to fx raised to the power r, and this is true for all r which are coming from capital R, means set of real number. As function satisfying the property fx plus y equal to fx into fy, for this if I replace y with x, I'm replacing y with x, then I can write fx plus x can be written as fx into fx, and this one can be written as fx square. So if I can replace y with 2x and then 3x, 4x, 5x, then I can obtain x plus n times x as fx raised to the power n plus 1. Or clearly f r into x can be written as fx raised to the power r, and this is true for r which are coming from set of real number. So option C is correct, and you can see in all these for all these given examples as e raised to the power x, e raised to the power minus x, and e raised to the power x, graph of the function is above the x-axis. So we can say all images are non-negative. So option C and D are correct.